Okay, this is the last video segment, and what they're asking is the following. Let's take this first problem, for example. Yeah, let's take this first problem. Notice that the amplitude is 1. There is no phase shift, and the value of k is equal to 100. That means that the period 2 pi over k is 2 pi over 100, which is pi over 50. Okay, so what am I saying here? Just a second. Yeah, right. The period is pi over 50. Right. I have the value of k, and period is 2 pi over k. You just plug it in, you get pi over 50. So if I was to plot this thing, I will go from 0 to pi over 50, and I will go between the height of 1 and minus 1. So this is the appropriate rectangle. This is plus 1 and this is minus 1. And if I were to sketch this graph, it starts up here, goes to 0, and then goes to minimum minus 1, goes back to 0, and goes back to 1. And then, of course, it repeats. That's what these problems are saying. That's what the appropriate rectangle means. Let's do another one. Let's get through this. Let's get through these. Okay. All right. Let me do this one. Amplitude is 3. No phase shift. The value of k is 120. That means period is equal to 2 pi over k, which means pi over 60. So if I was to draw that rectangle where everything is going to, or a frame if you want, some books call it frame. So we go from 0 to pi over 60, and it goes between plus 3 and minus 3. It goes between plus 3 and minus 3. So this is the rectangle. And if I was to sketch the graph of this sign, so it goes like this. Starts here, goes to 0 again, goes to peak, goes to 0, goes to another peak, negative peak, which is trough, and it goes like this. And if you were to repeat this thing, it'll keep going like that. Okay, next one. Do this. All right. Again, there is no phase shift here. So if you look at this problem, A is 1. B is 0. K is 1 over 40. And if we write period equal to 2 pi over k, this is going to be 80 pi. 80 pi. So if I was to draw this thing, it'll go from 0 to 80 pi, amplitude 1 and minus amplitude 1. So the plus 1 on the top, minus 1 at the bottom, and this is a sine curve. So if I was to draw a sine curve, fit it in there. It's right there, and it should end there, there. And of course, it keeps going on and on and on forever. And this other one is exactly the same shape, except that maybe we should finish it. Okay. Except that it's cosine. Everything is the same. Period is the same, and just at the cosine, and the period is the period is different. A is 1. shouldn't have said the same. A is 1. Okay. A is 1. B is 0. K is 1 over 80. That means period is equal to 2 pi over K, which is 165. So if I was to draw this, I go from 0 to 160 pi. The height above and below is plus and minus 1. Plus 1 here, minus 1 here because of this amplitude. And I have to put a cosine in there. So if I was to fit a cosine, cosine starts there, ends there. It peaks downward in the middle. So you go like this, and then it goes on and on and on. If you want to know what these points are, this is 80 pi, for example, halfway between these two, and this is 40 pi, and this is, yeah, what's this? 120, yeah, 120 pi. All right, we're almost done with this homework. Yep. Okay, it says put this stuff in your calculator, and I'm going to do that. So let me see. I'm going to do this thing with my calculator, TI-83 calculator here. Okay, so let's turn it on. Turn it on. Okay, what's the mode here? The mode has to be on radians, so it is on radian. You can see that right there. Okay, very good. And then I'm going to go and type in the functions. The first one is going to be clear this. The first one is going to be x squared. So here is the variable x, and this is squared. No, x squared. That's what I meant. Good. The next one, enter. Okay, enter. I don't think this thing works. Actually, let me clear this stuff. Let me move up. I screwed it up. Okay. X squared. There. That's good. Then we go to the next one. Negative x squared. There is your negative x squared. Enter. And I believe this other one was x squared times sine of x. Okay, so let's go x squared times, where's the multiplication, sine of x, and close it. Now the window is extremely important because default windows from -10 to 10. Well, I mean, you have to decide, so graph it. We're going to change the window here. This is x squared, there's one x squared, and this is x squared sine of x. The only thing is that this window height-wise is not big enough. So let me increase the size of the window here, going from say for y, let me go from -20 and see what happens. -20 to 20. Yeah, 20. And graph it. Oops, 0, 0, 0, 0. Good. And then where's the graph? X squared minus x squared. Yeah. Okay. So let me reduce or either increase y or reduce x. Either way. So let me reduce x. Okay. So window. For example, I do it from minus 5 to 5, minus 5 to 5. Oops. Clear. Window. Okay. So let me go here. clear this, negative 5, and then I go down to 5, clear this, to 5. I leave these heights the same, so graph it. Yeah, so this is x squared sine of x. Alright, so this takes care of that. What's the other problem? X minus x and x cos x. So let's go ahead here, clear the functions. Let me go clear my functions. And so that's going to be, for example, x times cosine of x, close the parentheses. Then we go to the next one. So that's going to be minus x, negative x, and okay, that's good. And this one I'm going to clear it, and positive x. Okay, I keep the window the same as the one that we just did. So graph it. There's going to be, of course, this is going to be x cosine of x, and this is going to be x and minus x. Now, what I would like to do is change the window here to see this thing better. So these y values are too big. So I'm going to go from minus, let's say minus maybe 4, minus 4. I'll make it 5. Okay, minus 5 to 5, and graph it. There is x cosine of x. There is x, or minus x, and there is x. Okay,